Okay, in this video, we're going to be doing the May 2022 SAT Math Non-Calculator section. In the video, I'm going to do these kind of the way that I would do them if I were taking the exam, but more I'm going to do them in ways that I think anybody could solve them. So I might explain multiple perspectives or give ideas about what I would do if I didn't understand the problem. We'll see as we go. So let's take a look at the first question. Certain university offers courses that are either 3 credits or 4 credits per course each semester. Student registers for a total of 16 credits for the fall semester. Which equation represents the possible number of 3 credit courses, which they're telling you is the variable x, and 4 credit courses, which they're telling you is the variable y, that the student could have registered for? So you might blow right through this problem, get it right, and move on. Maybe you don't. So a careful reading of the problem helps. So there's a total of 16 credits. So like whatever you're doing, you kind of know that it's going to end up equaling 16. Now they're telling you that a 3 credit course is X. So like if you took 2 3 credit courses, you would have 2 times 3, which is 6 credits. And then a 4 credit course is Y. So if you took like 5 4 credit courses, you'd have 5 times 4 credits or 20 credits. That's the kind of thinking you want to do. So, I mean, we're saying there's going to be 16 total. So, like, right away, if you want to eliminate, you could eliminate A and C as options. Now you just need to pick between B and D. And you need to account for that, like, 3 credit, 4 credit thing. I'm leaning toward B at this point. But we do know it's X 3 credit courses, so that would be 3 times X. There are Y 4 credit courses, so that would be 4 times Y. And that's your equation. So, the answer is B. So, there's a lot of ways you could do this. Again, you might have, hopefully you just blow through that one. But if not, I do think that reading carefully is the key to this. When I'm doing practice tests, I often get like the first 1 or 2 questions wrong because I just do not read them. I just assume I'm going to know the answer, and that's a really bad strategy. So read carefully, make sure it's not asking something that you don't think it is. And then if you are confused, just kind of like play around, start thinking about like, well, what if X was a certain number? What if Y was a certain number? For example, say X is 6 and Y is 5. So if X is 6, then you know that you're going to have 3 times 6. And if Y is 5, you know you're going to have 4 times 5. And that's going to have to equal something. So now you sort of have an idea like of the structure of this thing. It's going to be 3X plus 4Y. And then the only question is like, what should it total up to? And the problem told you. So that's what I would do on the first one. Pretty straightforward question. As you can tell, the video will be much longer than if we just did the problems. I don't know if I should make a separate video where I just like go through and straight up do the problems and show you that like you can use these strategies to do it in a shorter amount of time. I don't know. We'll see. This is the first one I've done of just like SAT math. So let's look at the next question. Somewhere. Here we go. The function f is defined by f of x equals x plus 3. What is the y-intercept of the graph of y equals f of x in the xy plane? So one thing you could do here is, one option is just know the answer. I mean, the answer here is definitely 0, 3. That would be D, and I would move on. If not, you can create a graph for sure. This is non-calculator, but I mean, it's a graph. You could plot points if you needed to. If x is 0, y is 3, which is actually the answer, so that's a little weird, but it has a slope of 1. All these things are useful to know. So, I mean, this is y equals x plus 3. This is definitely the y-intercept. It's where it hits the y-axis. So at that point, I'm definitely selecting 0, 3. It's really useful to go into this thing knowing what y-intercepts and x-intercepts are. I would not try to take the exam without knowing that. So a y-intercept is when x equals 0, and then an x-intercept is when y equals 0. So knowing that is really useful. Another way of finding a y-intercept is to think it's going to be the ordered pair 0, comma f of 0. So you can take 0 and plug it into whatever function you're given. That'll give you an ordered pair 0, 3. All right, that's another question down. Let's take a look at the next one. So this one, if you don't read it, looks a little intimidating because you might run into quadratics on this thing. You might run into exponential functions on this thing. In this case, read the question. The graph shown models the monthly revenue in millions of dollars for a particular marketing company from June 2009 through October 2010. According to the model, which of the following is closest to the company's monthly revenue? So it's a graph of monthly revenue. Which of the following is closest to this company's monthly revenue in millions of dollars for June of 2009? But look at the thing on the graph here. We're looking for June of 2009. The graph represents number of months after June of 2009. 0 would put you in exactly 0 months after June of 2009 is June of 2009. So we just want this y-intercept. There's another question about a y-intercept. Now you have to figure out, like, what is that number? Well, each of the horizontal lines you can see is 10, right? You go like 0 is labeled, nothing at 10, 20 is labeled, nothing at 30, 40 is labeled. So each of them is 10, you're a little below that. The answer here has to be 8.5. This is one where you really benefit from reading, because I think some people would be intimidated by the graph before it even started. Some people are intimidated by the little paragraph that is the question, but just know going in, like, you're going to face this kind of thing, and they're never as hard as you maybe think they're going to be. Okay, let's take a look at the next question. So in the figure shown, right triangle ABC is similar to right triangle EDC, where angle ACB is congruent to angle ECD. So ECD, those are the two that meet at the point C in the diagram. Those are the two angles that are congruent. Also, just kind of visualize it. Like, I would take the triangle ABC and just like flip it over so that it's inside of triangle ECD, and it would just kind of fit there. Maybe I should have drawn that out, but I didn't. So the question is, if AE is 15, what is the length of CE? So CE is the thing we're looking for. We should name that the variable. So let's call that X, because that's the unknown. Now, what else do we know? We definitely know that AE is 15. AE is that long horizontal segment. So I'm going to draw like all the way across. That's 15. Now, what is the missing part, right? So we know that CE is X. We know the full thing is 15. The missing part must be 15 minus X. I think labeling the figure is kind of a really good strategy here. So now what we're going to do is we're just going to put parts over parts. So I'm going to go like the horizontal part of the triangle over the vertical part. So for the first one, I'll have these two things. I'll have the horizontal part is X, the vertical is 6, and then that's going to be equal to the same parts in the other triangle. So it's going to be equal to, we have a horizontal part of 15 minus X, and we have a vertical part of 3. So 15 minus X, and then over 3. Now we just need to solve this. I'm going to cross multiply. So I'll multiply the left-hand side by 3, the right-hand side by 6. There are like some simpler things you could do, but this is going to work, so why not? So this gives me this. Do not forget to distribute. And then I'm going to add 6x to both sides. And I'm going to divide both sides by 9. And I will get x equals 10. So x is what we're actually looking for, right? So we were looking for CE. We now know that x, which is CE, is 10. That's our answer. If you aren't really sure what to do after you kind of set up this proportion, x over 6 equals 15 minus x over 3, at this stage, you could just start plugging in the answer choices. One of them is the right answer, so that would be kind of a winning strategy on that. I think it's better if you can actually solve it, but plugging in, substituting, always viable. Let's take a look at the next question. Which polynomial is equivalent to the quantity 12x to the fourth minus 5x plus 18 plus the quantity 6x to the fourth plus 13x squared plus 7x minus 9? Okay, so we're just being asked to add these. This is like a pretty straightforward like algebra 2 type of question, maybe late stage algebra 1. You find things that have the same exponent and you add their coefficients. So for example, I see 12x to the fourth, I see 6x to the fourth. If you have 12 Jolly Ranchers in one hand and 6 Jolly Ranchers in the other hand, how many Jolly Ranchers do you have? You have 18 of them. So there's 18 x to the fourths. Now look at the answer choices. 2 of them have 18x to the 8th. So we can just cross those right out. Those are not the answer. So the next thing we look at will probably tell us the correct answer here. Next we have, if you're going in order of exponent, the next highest exponent you'll see is x squared. And there's only 13x squared. The other part doesn't have any x squareds. So there's 13x squareds. Look at the answer choices. It has to be C. That is the answer. Now, if you don't like this approach, another approach would be to actually add them. What I would do in that case is I would use placeholders for the exponents that don't show up, right? So there's 12x to the fourth. There's no x cubed, so do 0x cubed. There's no x squared, do 0x squared. Minus 5x plus 18. Now line up exactly underneath this the corresponding parts of the second thing. So you'll have 6x to the fourth, you'll have no x cubed, so 0x cubed. But here you have 13x squared, so write it down, 7x's and a 9, minus 9. And then you just add down, right? So 12 and 6, which is 18, x to the fourth, and then you'll have no x cubes. You'll have 0 and 13 x squareds, you'll get 2 x's, and you'll get plus 9. We already knew the answer. That's another strategy. So like I said, I'm going to go through like multiple ways of doing it, just in case. Some people don't like shortcuts. Other people work really fast when they're doing kind of like traditional approaches. I just want you to know, like, anything is viable. The objective on the SAT is to get the answer. It makes me a little sad to say it. It's not about doing the math. It's about getting the answer. So whatever method you're using is the right method if it's working for you. Let's look at the next one. The equation y equals x plus w over z relates the positive numbers x, w, x, y, and z. Which equation correctly expresses x in terms of w, y, and z? This is like a very wordy way of saying, basically, right here, all this means is solve for x. They want you to take y equals x plus w over z, solve it for x. So let's do that. I mean, some people will tell you to substitute values, things like that. That will work, but I think the traditional math method here is probably actually easier. So I have this. I'm going to multiply both sides by z and get yz equals x plus w. I'm going to subtract w from both sides. Yz minus w is equal to x. Then I will look at the answer choices, and I see that option option A, I think, should actually be the answer. I have chosen wrong on this one in my like prepared thing. So x is equal to, I believe, yz minus w. And you can see I have made a mistake. I do it sometimes. Actually, maybe I do it more than I wish. I will do the problem and then choose the wrong answer. Fun times, right? We've all been there. All right, let's take a look at the next one. G of x is negative 0.038x plus 2.136. That's kind of scary. The given linear function g models the annual percentage increase in the population of India x years after 1990. X is in years after 1990. What is the best interpretation of g of 20 equals 1.376 in this context? All right, so I look at this and my first thought is that we have said that x represents a number of years after 1990. So x, we're doing g of x, so when you see g of 20, that 20 is telling you that x is 20 years after 1990. So x represents 20. So whatever you answer here, it's going to be about being 20 years after 1990. Look at the answer choices. Option A, 1.376 years after 1990, cannot be the answer. B, 1.376 years after 1990, cannot be the answer. Get rid of them, right? So this type of problem sort of scares some people because there's a lot of words, but those words have meaning. And like in math, you can usually boil it down pretty quickly to like very specific things. In this case, we know x is years after 1990, A and B are gone. Now the question becomes like, what do you do between C and D, right? C is the percent increase in population of India was 1.376% over the previous year. D, India's population was approximately 1.376 times its population in 1990. So in this case, I'm going to look back at the problem. The given linear function models the annual percentage increase in the population of India X years after 1990. The annual percentage increase. So which of these mentions an annual percentage increase? It's really like a reading comprehension problem, which like, I don't know, you might feel is unfair. I think it's okay. I do not like this problem, I will be honest with you. If it weren't for the context clues, I don't think I would be interpreting this correctly. So I don't know. I'm going with C. I know that C is the answer. I also know, just from experience, if you read D, it says 20 years after 1990, India's population was approximately 1.376 times its population in 1990. That's actually going to represent an exponential model, and so I could have ruled that out as well. That's more of like an advanced way of ruling things out, but it definitely would have worked. All right, let's take a look at the next question. For the quadratic function f shown, a, b, and c are constants. For the graph of y equals f of x in the xy plane, the quadratic function f opens up, and the coordinates of its vertex are both negative. Okay, so I think it'd be good to start with a picture, because like, what does it mean for a quadratic to open up? That's what it means. If it opens up and it's of the form a times x minus b, x minus c, we definitely know that a is greater than 0. So that's a first step, because if you look at the answer choices, that eliminates 2 of them right away. So now we just have to choose between c and d. They both have a greater than 0. Look at the choices. One of them has b and c both less than 0. The other has b and c both greater than 0. Which of those choices is going to make the x-coordinate of the vertex negative? So I think I know the answer. I think that it's C. But if I didn't know the answer right away, what I would do is I would just like pick numbers. So I'm choosing 1 for A because it's the easiest thing in the world. I'm choosing B is -2 and C is -3. If I choose that, that would make the x-intercept -2, 0 and -3, 0, which would make the x-coordinate of the vertex. It's always the average of the x-intercepts. So there's a lot of things that you should probably know about quadratics going into this. Some of them are how to manipulate this form of a quadratic, A, the quantity x minus b, x minus c. I think I'm going to make a whole separate video on just like the quadratic stuff you need to know. I think that'd be very useful. In this case, you will definitely have a negative x-coordinate for your vertex. So this is definitely the answer. But what if we chose the other one, right? All of them are positive. Well, then you would get something like this. You would have like, I don't know, x minus 5 and x minus 10. So our x-intercepts would be at 5, 0 and 10, 0, which would make the vertex at 7.50. That's a positive coordinate. That cannot be the answer. So C would be our answer. This is a pretty straightforward problem as long as you are willing to kind of like play with numbers if you don't immediately see what's happening. But maybe you do immediately see what's happening and you just kind of like dive in. Up to you. All right, let's take a look at the next problem. We've got 2x plus 6y equals 2. Suspiciously, everything in there is divisible by 2. I don't really know why they did that. And then we also have 2, the quantity 2x plus y equals 20. That's even more annoying because you could just divide both sides by 2 and have 2x plus y equals 10 and kind of be like going with it. But the question is, how many solutions does the given system of equations have? All right, so our first equation was 2x plus 6y equals 2. That's fine. Let's play with the second one, right? The second one was 2 times the quantity 2x plus y equals 20. I'm definitely going to divide both sides by 2. So that'll give me 2x plus y equals 20 over 2, which is 10. Now, if we just look at these, they both have 2x, but then there's 6y versus y. These are not parallel lines. For these to be parallel lines, it would have to be 2x plus 6y equals something, 2x plus 6y equals something. So as soon as we get 2x plus 6y equals 2, 2x plus 1y equals 10, these lines definitely intersect. It is not possible for lines to intersect twice. They either intersect never, once, or infinitely many times. So C is like a bizarre answer to begin with. So the answer here is definitely B. What we could do, though, is if you don't like... So I would have answered that and moved on. If you don't like that, what you can do is you can set both of them equal to just y, right? So I'm going to take the first one. I'm going to subtract 2x from both sides, divide by 6. You get y equals negative 2x over 6 is negative 1/3 x, plus 2 over 6, which is 1/3. If you do the same thing for the second one, 2x plus y equals 10, you will get y equals negative 2x plus 10. These have different slopes. If you have different slopes, you must intersect. And there's only one intersection point. So we knew they intersected. This is another thing that's extremely useful to know. If you have parallel lines, meaning they have the exact same slope, you'll have 0 solutions. If you have different slopes, you have to have one solution. And then I tried to draw this, but like you can't really even tell. If they're the exact same line when you solve for y, then you're going to get an infinite number of solutions because there's actually only one equation really going on there. That's all useful to know going in. Let's take a look at the next question. Oops, same line, infinite solutions. All right, what is the sum of the solutions to the given equation? This is an absolute value equation. The absolute value of 2x plus 6 plus 4 equals 8. All right, step 1, don't freak out, right? So don't freak out. You got to get the absolute value thing by itself. Like this equation to begin with might as well just say a plus 4 equals 8, solve for a. So to do that, I would subtract 4 from both sides. So I'm calling a the absolute value of 2x plus 6. Subtract 4 from both sides is equal to 4. Now, absolute value, what you're going to do is the thing inside the absolute value is equal to the number on the other side, or the thing inside the absolute value, 2x plus 6, is equal to the opposite of the thing on the other side. That's your go-to. You're going to do it every time. Absolute values can't be negative. So if the absolute value is around it, if it said the absolute value of 2x plus 6 equals negative 4, you would just be like, nope, can't do it. But the absolute value of 2x plus 6 equals 4. You put 2x plus 6 equal to 4. You put 2x plus 6 equal to negative 4. Now you just solve each of them separately. So for the left-hand one, I'm going to subtract 6 from both sides. I'm going to divide by 2. And that's one of the solutions. For the one on the right, I'm going to subtract 6 from both sides. I'm going to divide by 2. That's the other solution. Now we look at the question and we say, what is the question? Sum of the solutions, I have to add these together. So -1 plus -5 is definitely -6. That is the answer to this question. I would not freak out about this at all. I don't really think there is an alternative way of doing this because they're asking for the sum of the solutions. So we couldn't like just pick numbers and plug them in. But the actual algebra, not very intimidating if you are not afraid of absolute value, which there's no reason for you to be. So that's that problem. All right, let's take a look at the next problem. The shaded region shown represents the solutions to which inequality? Okay, so I look at this and I think to myself, I'm going to write the equation of that line, right? So we've got a line that is going through the point 0, 3 on the y-axis. It's going through the point -1, 0 on the x-axis. So if you go 1, so start at -1, 0, go 1 over, you go 3 up. The slope is 3. The y-intercept is 3. That line is definitely y equals 3x plus 3. So now that I know that, I want to compare that to the answer choices. Well, the answer choices are kind of written as like 3x minus y or 3x plus y. Looking at my equation, y and x are on opposite sides. I don't see how I could get them on the same side and have it be a plus in between them. So I'm pretty sure C and D are like out. But what I'm going to do anyway is I'm going to rearrange it so it looks sort of like the answer choices. So I'm going to subtract y from both sides and subtract 3 from both sides. So that'll give me -3 is equal to 3x minus y. Okay, so looking at that, 3x minus y appears in A and B. It does not appear in C and D, which I had already mentally crossed out anyway. Those are gone. Now, how do I choose between the remaining answers? I noticed that the point 0, 0 is in the shaded region, so I'm going to check to see if 0, 0 satisfies these inequalities, right? So for part A, I would do 3 times 0 minus 0 is 0, less than or equal to -3. That is not true. 0 is bigger, so this is not the answer, which means B is the answer and you could move on. I'm going to plug in anyway, but like you should just move on because you know the answer already. If I plug in, I get 0 is greater than or equal to -3. Obviously true because we already know it's the answer. I think that's about as straightforward as they get. I don't really have any alternative things that I would mention here because the problem doesn't really allow for other methods, I guess. I mean, you could pick more than one point and plug it in if you're completely lost. Just pick points that are in that shaded region and test. Eventually, you're going to get the answer. But I think it's better to actually do the math on that one. All right. The graph shown models the height y in feet of a volleyball x seconds after it was hit by a player. They like to give a lot of context, and then I would argue that in most cases you do not need the context. Which equation represents the graph, right? That's basically what it's saying. What's the equation of this graph? But it says which equation represents the relationship between the height of the volleyball and the time since the volleyball was hit. But again, if you are presented with this problem and these answer choices without any of the words, so you're just given the graph and the answer choices, you would know what to do. So like, don't let the words intimidate you. Also, look at the answer choices. Every single one of them has a -16 in front of it. So that's not really going to be relevant to like how we solve the problem because obviously -16 will be a part of it. So I'm not super worried about that. I do for these sorts of problems, I like to find the vertex. So the vertex is that turning point, the maximum or the minimum. This is occurring at 0.25, 6. So our vertex is 0.256. And then it comes down to what do we know about quadratics? Well, one form of... We already saw the other form, right? A, the quantity x minus B, quantity x minus C. There's another form that we should be familiar with, and it looks like this. I'm sorry. Sorry, I ruined it. Based on the vertex, I mean, just look at the answer choices and look for 0.25 and 6 to show up anywhere. They show up in D. That's definitely going to be the answer. But why is that the answer? Here's the reason. One of the forms that you should be very familiar with is y equals a, the quantity x minus h squared plus k. In that form, the vertex is the ordered pair h comma k. So 0.25 is h, 6 is k. Plug them into that formula, look at the answer choices, it has to be D. I don't honestly know where they're getting the other options, so I'm not really sure how to tell you what's wrong about them. So that's what I would do. Just be really familiar with that. You will be okay. Let's take a look at number 13. All right. Trapezoid A and trapezoid B shown are similar. The length of each side of trapezoid A is 8 times the length of the corresponding side of trapezoid B. That means that they are similar figures, right? You just multiply the length of one thing by 8, you will get the length of the corresponding thing, the other thing. I'm saying thing too much, but I hope you know what I mean. The area of trapezoid A is how many times as large as the area of trapezoid B? Now, this is a geometric concept that I definitely recommend you just commit to memory. This is worth memorizing. All right, for similar figures, you have a scale factor. The scale factor tells you how to go from one to the other. In this case, A is 8 times the length of B. So that's our scale factor, it's 8. When you have the scale factor, the ratio of the areas of those similar figures is always just going to be k squared. It's the scale factor squared. If there's volume involved, it would be k cubed. So memorize that so that you can just do it. This problem is like a free points problem if you have that memorized. So in this case, we're aware that it's 8 times. That means that k is equal to 8. We're being asked about areas. Area square the scale factor. So the answer here is going to be k squared, which is 64, and that is going to be our answer. It's very useful to know that. That's like a really important one. It comes up, obviously. This was an actual SAT, so make sure you know that. All right, let's take a look at the next problem. The function f is defined by f of x equals -8, so it's quantity -8 times 6 to the x. So that x only goes with 6. Minus 4. I believe that that's what they're kind of testing here, is if you know how to read that, because what they're about to ask you is what is the y-intercept of the graph? We've already done y-intercepts. So quadratics came up twice, y-intercepts are coming up twice. These are really common topics. Make sure you really know them. The y-intercept, I think the easiest way to think about it this time is that it's going to be the point 0, comma f of 0. So we're going to take, it's where x equals 0. So we have to take 0 and plug it in. They want to see if you can do that. So f of 0 is going to be -8 times 6 to the 0 minus 4. All right, so we're supposed to do exponent, well, like parentheses, but everything in parentheses is already simplified. Like -8's not getting better, 6 isn't getting better. Exponents, so exponents, we do 6 to the 0. Anything to the 0 for us is going to be 1. So we have -8 times 1 minus 4. -8 times 1 is -8 minus 4, -12. Our ordered pair is going to be 0, -12. So our answer is definitely A. One thing I will mention on this problem is if you get a little bit lost and you're not sure what to do, look at the answer choices, right? Every single answer choice has x equals 0. The only thing you could possibly do to answer this question is take 0 and plug it in and see what you get. So always be aware you're doing multiple choice problems when you're doing multiple choice problems. If you're doing the open-ended, you got to really know the stuff. But on multiple choice, like they told you, like you've got to let x equal 0 and see what happens. All right, let's take a look at the next question. So this is actually the last of the multiple choice questions in this non-calculator section, and then it will become open-ended. And also on the actual thing, you're going to have to go way faster than what I'm doing because I don't remember exactly how much time you have, but it's not this much time. I mean, I could look. Hold on, let me look. You got 25 minutes for the full thing. I am over-explaining excessively. If I were doing this, I would have been done a long time ago. But that's okay, because we're talking about ways that we can solve these. Now, this question is kind of interesting because I got my copy of this from the internet. This has a typo, and I don't know how people know that or whatever, but if you search this up, you will find out that the actual question, so it's which of the following expressions is equivalent to, that expression is not the real expression. The real expression is, that's a typo, it's the quantity 2q plus root 2r all to the 2/3, where q is greater than 0 and r is less than 0. I am not sure why they tell us that, because I feel like that could potentially mess things up a little bit. But anyway, we're going for it. So I'm just going to do the math, but there's like some serious math in this problem. It's the most mathematical of all the problems that we've done. And it's lucky because it's the last one in the multiple choice part. I don't have enough experience to know if they always do that yet. I will someday, but and you should too. You should do every SAT that you can find. Practice with the real thing. Get the best score you can. Here's some math that we need to know. So it's something to the 2/3, right? So if we have a to the b over c, one way to interpret that is that it is the cth root of a to the b. So you can raise a to the b power and then take the cth root of that. That's one option. The other option is that you can take the cth root of a and then raise that to the b power. You can do them in either order. So we have to choose which one we want to do. If you look at the answer choices, basically all of them are like root 3. So I'm thinking what we want to do is the first one. We want to take a and raise it to the second power. So I'm going to rewrite this thing. I'm going to say it's root 2q plus root 2r squared, and then I will take the cube root of whatever I get there. But now we got to talk about how to square this thing. So as I said, very, very mathematical. This is very mathy. To square something, so I'm going to talk about a plus b squared. I have this memorized. You should have this memorized. You don't want to have to think about it. A squared plus 2ab plus b squared. Okay, so with that in mind, we can kind of write down what's going on. So this will be the cube root of, square the first thing, so that's 2q, multiply them together times 2, so it's going to be just plus 2 root 2q root 2r, and then square the last thing, so if you square root 2r, you're just going to get plus 2r. And then we can like close this thing. All right, look at your answer choices now, right? So your answer choices now, definitely you're choosing between C and D. So now we need to figure out why the answer is not C, but is instead D. But look how many 2's there are in that middle term there. We got 2, root 2q, root 2r. There's definitely more than just 2 root qr. So even if I didn't know how to simplify this, I would be choosing D at this point because C just doesn't have enough stuff. So I would do that, and I would feel comfortable doing that. I do happen to know, however, how to simplify this, so I don't have to rely on that. And the more math you know, the more that you can also fall back on like just straight up doing the problems, and I recommend it. So I've taken root 2q, root 2r, and just made it root 2 times root q times root 2 times root r. Root 2 times root 2 is 2. Root q, root r. You have those two radicals, you can pull them together. This is like the very mathy part. Also, you can blow through this if you know what you're doing. You don't have to like talk it all out. So really we have this 2 times 2 root qr. That's where we're getting the 4 from. So that's it. That's it for the multiple choice. And now what we're going to do is we're going to answer a couple of open-ended questions. And we'll see how this goes. So they're not harder. They're actually, I would argue, like a little bit easier, but they're open-ended, so you have to like fill in. They're grid-in questions. All right. If 3x minus 9 equals 6, what is the value of 2x? They love this kind of question where basically you solve for x and then multiply your answer by something, right? So I'm just going to solve this. 3x minus 9 equals 6. I don't know if there's supposed to be a clever way to do it. I'm going to add 9 to both sides. 3x is equal to 15. I'm going to divide by 3. X is equal to 5. And then the question is, what is 2x? So I'm going to double that. So 2x is going to be 10, and that's our answer. So I would grid that in. I would grid in 10. All right, let's look at the next one. Like I'm saying, I think that these are actually like, they tend to be easier, but I think people are more afraid of them for whatever reason because they don't have answer choices, I guess. All right, 17. What is the positive solution to the given equation? So square root of x squared minus 9 equals 4. I don't think we have much choice here. I'm going to square both sides. Generally speaking, sort of a dangerous thing to do in math, to just square both sides. On the SAT, not as dangerous. So when I square a square root, I'm just going to get the thing inside the root, x squared minus 9. Square 4, you get 16. I'm going to add 9 to both sides. X squared equals 25. I'm going to take the square root, so I'm going to get x is either plus or minus 5. And then the question is, what is the positive solution? So 5. And there you go. I mean, like, not the end of the world. Let's take a look at the next question. Line P is defined by 2y plus 4x equals 9. Line R is perpendicular to line P in the xy plane. What is the slope of line R? Okay, R is perpendicular to P, so we need to know what perpendicular lines, what relationship they have. The perpendicular lines, perpendicular lines, the slopes are opposite reciprocals. Now, because that's a little, I always say it's just like, I always say opposite reciprocal. But, for example, if the slope was 3/8, which it's not in this case, but if the slope was 3/8, then the slope of the perpendicular would be the opposite, so it'd be negative. The reciprocal is 8/3. That's an opposite reciprocal. They also multiply to -1, which is a useful thing to know. So to do this, what I'm going to do is take the line that I was given, solve for y, identify the slope, and then take the opposite reciprocal of that. So I'm going to subtract 4x, and then I will divide by 2. The only thing that matters is the coefficient of x. So like if you want to ignore the 9 at this point, you totally could. But we have 9/2 anyway. So the slope here is -2. I think it's convenient to write it as -2/1. And then the perpendicular slope is going to be the opposite, so negative. The reciprocal of -2/1 is -1/2. So it's -1/2, which is +1/2. And that's what we would be gridding in. All right, let's take a look at another one. Number 19. If 2x/3 minus 2 equals x/3 plus 1, what is the value of 2x? And again, I don't know if they want me to be clever about solving this, but I'm not going to be clever about solving this. I do think, so I'm very comfortable working with fractions, so sometimes I'll just work with them. A viable option here is to just multiply every single thing you see by 3. You'll get 2x minus 6 equals x plus 3. Solve for x, and then double it. I'm going to work with the fraction. So I'm going to start with the original. 2x/3 minus 2 equals x/3 plus 1. I'm going to subtract x/3 from both sides. So 2x/3 minus 1x/3 leaves you with just 1x/3. Minus 2 equals 1. I'm going to add 2 to both sides. x/3 is equal to 3. Multiply both sides by 3. X is equal to 9. That's not the question. The question is, what is 2x? Always be on the lookout for that. That's part of why we practice for this thing. Because, like in a normal situation, someone would not at the end of a question just be like, okay, what's 5 times the thing you got? Like nobody would do that. The SAT does it all the time. I'm not sure what they think they're testing, but that's what they do. All right, let's take a look at number 20, the last one in this section. Again, the real deal, you're going to have to go a lot faster than I'm going. But on the real deal, you don't have to explain each question in multiple ways and talk about how you should solve it and what you should know. You should just be doing them. So I think if you practice, you will be fine. All right, points A and B lie on a circle with radius 4 meters. Arc AB has length meters. It seemed like they were gonna like put a number there, but it's just length in meters, measured in meters. I don't know. The length 4 pi over 5 of arc AB. Okay, 4 pi over 5 meters, I guess, of arc AB is what fraction of the circumference of the circle? So I don't know if this also has a typo in it somewhere, but it's doable the way that it is. So we need to know what circumference is. You should really know the circumference and the area of a circle. I do think they give you those formulas, but like I don't know what they do on the computer version. But the circumference is definitely 2 pi r. We know the radius is 4. So we actually know that the circumference is 8 pi, or 2 pi times 4, which is 8 pi. So the full circumference is 8 pi. We just want to know what fraction of 8 pi 4 pi over 5 is. So that just means put 4 pi over 5 over 8 pi and then simplify it. That's all this question is saying. So we have this. You might find it convenient to think of it as 8 pi over 1 so that you can, I learned this as keep, change, turn. Keep the top, change division to multiplication, and turn the bottom fraction over. I learned that. Some people are like, no, don't teach it that way. But like, that's how I think of it all the time. And I don't usually get them wrong. So I do think that's valuable. All right, I'm going to cancel the pi's. So I keep, change, turn. Got this. Cancel the pi's. You could cancel the 4 and the 8, but like sometimes I think that's sloppy. So I'm just going to put 4 over 40. And then 4 over 40, divide everything you see by 4. You'll get 1 over 10. That is our answer. And that's the end of this section. So I don't know if I'll keep doing these SAT type videos. Maybe, I guess I'll see how this one does because it was a big time investment. But I hope this was helpful, and good luck.